Hi folks, my name is Matt Bullock again, one of the technical marketing engineers with the Enterprise Networking Group at Cisco. Today I'm going to talk to you a little bit about the packet flow in an integrated services router. This is going to be across the whole range of integrated services routers at Cisco. ISRs, if you're not familiar with them, are really our core branch platform. So these are the routers that you'll find in a remote site, in a retail store, in a doctor's office, in a bank branch, those types of things. We have a pretty broad portfolio of these branch routers, mainly because they fit into a lot of different sized branches. So you have your really small mom and pop kind of shop that'll have a little small device or a small office, home office type of thing. It might be an 800 series, for example. Moving up to your really large retail chains might have something like a 3900, 3900E series, or your large campus sites, your really large locations might have one of the newer 4451X devices. Now, within this portfolio, we have what are called the ISR G2s, which is basically everything below a 3900 series, and then the newer ISR 4451X, which is just a separate member of the ISR family. Specifically within the architecture within packet flows that we're going to be talking about today, I'm going to focus really on the core of the ISR G2 series and the new 4451X, because we have a little bit of different block diagrams, a little bit of different architecture between the two boxes here, and of course a slightly different packet flow. But you also see how they're very similar at the core of the systems itself. Now, the other boxes in the ISR family, we're certainly not leaving those out. They're just generally going to be a subset. They're going to be much simpler than the rest of the ISR G2s and 4451X. So the 1921s, the little guy you see there on the left, and the 800 series are generally much simpler devices than the rest of the portfolio. And how they really differ, if we take a look at the ISR G2 family themselves, this is really the 1941 all the way up to the 3900 and 3900E series. The 800 and 1921 are going to look exactly the same. They're just going to be missing this great big MGF block in the middle here. Everything else is going to look exactly the same on those devices. However, they're not quite as modular as the larger systems, meaning they don't have as many module options. So there's going to be a lot fewer connections within the system. So focusing on the core of the ISR G2 portfolio, the 1941s and above, this is really what the system looks like inside. We have a single CPU complex that's responsible for running Cisco IOS, doing all of the layer 3 forwarding of the system. That's really the brains of the ISR G2 family. Alongside of that, we have this device called an MGF, or a multi-gigabit fabric. The MGF is really just a fancy term for a layer 2 switch inside of the router itself. Now, you might ask yourself, hey, this is a layer 3 router. This is doing a lot of advanced layer 3 and above type of things to a packet, to an application going through the branch. Why do you need a layer 2 switch inside of that? Well, it actually comes into play really nicely when you have modules, when you have traffic inside of the system itself, inside of the branch, that really doesn't need to go all the way up to the router's CPU brain for layer 3 and above processing, layer 3 and above features. If you have traffic, say, from one module to another that just needs to stay within the branch, needs to stay locally at layer 2 on a VLAN, for example, then there's no reason to send that all the way up to the router CPU. They can just get sent directly from one module to another at layer 2. A good example of this would be if you have one of the UCS E-series modules, which is basically a server module sitting inside of an ISR G2, say a 2951, for example. You might have a storage application there, a server application, maybe a video surveillance application running on that module. You might also have an Ethernet switch inside of the same 2951, for example. Well, it makes sense for local users on that Ethernet switch, or video cameras or access points or whatever in the local branch, to talk directly to that server module and the applications on it directly at layer 2, keeping all of that layer 2 local branch traffic off of the router's CPU brains. So I'll talk a little bit about that on the next slide in terms of how traffic actually flows through one module to another. Now, in the ISR G2s, we do have a lot of different module types that can fit into the systems with different connections between those. You see the green modules we have here, we refer to these as sort of our legacy modules. So these are modules that we supported since the ISR G1 days, so the previous generation of ISRs, that we still continue to support on the ISR G2s. The newer blue modules are actually the modules that are new to the ISR G2 that we introduced with this family, with this series. And you can see that these new modules, as well as the older modules, all have out-of-band connections directly between the CPU and the modules themselves. And this is specifically there for layer 3 connectivity. So old modules only have an option of this out-of-band path to the CPU. Newer modules have an option of that out-of-band path for layer 3 connectivity, or they have the option of an MGF connection for layer 2 connectivity to other modules. So the newer module types are going to give us a lot more flexibility in terms of how we can communicate with the system. The new EHWICs and the new SMs are going to be your interface module types. The other types, the ISMs or the internal services modules, and the PVDMs, the packet voice data module, are actually going to be internal components that are only going to be shared with the rest of the system. There's no physical interfaces on those, so you're not actually going to be sending packets through them, through those module types. The actual packet flow, if you're looking at just basic traditional normal layer 3 routing, that's all going to be done on the CPU brain of the system. So a packet will come in on a module. In this case, it's a newer enhanced HWIC in the system, go through the layer 3 CPU, the router CPU, and then find its destination module. In this case, it's an SM, a service module inside of the system. So this could be coming in on, say, a T1, E1 WAN module, or possibly an EHWIC gigabit Ethernet module, and it could be going out an SM module, either probably on something like an Ethernet switch, in that SM slot. So you've got lots of options there for layer 3 forwarding. Now this is true for legacy modules, those green modules there, or for the new modules, because they're all using this same out-of-band connection for layer 3 forwarding. The reason we do this is because even though we do have this MGF connection for our new modules, this is a shared connection here. It's a shared MGF connection with a shared trunk up to the router's CPU, because this is a layer 2 Ethernet switch. So for traffic that's going to stay local to the branch, it makes sense to send that traffic through the MGF. Anything that's going to be going through the CPU eventually, anything that's going to get forwarded at layer 3, it's up to the module. The module will generally try to send that traffic directly through that out-of-band link, because that's a dedicated path between each module and the CPU, and that's true whether it's a new module or not. Of course, legacy modules, that's the only option they have. No layer 2 capability there. Now, the really interesting thing with the multi-gigabit fabric comes into play with direct module-to-module communication, because when you have a packet coming in on a newer interface card, in this case it's an enhanced HWIC, basically a packet arriving that's going to get forwarded at layer 2 to some other entity in a system. In this case, this could be an EHWIC switch module, an Ethernet switch. Maybe it's going to a UCSE series blade in the SM form factor. Someone local in the branch is accessing an application on a virtual machine running on that blade. They would send that traffic across a VLAN through the MGF directly to that service module, where it would get consumed. It would have whatever needs to be done to it there. The same thing happens in reverse. When that server needs to send a packet out directly to the LAN, it'll go straight through the MGF and out the HWIC. The benefit of this is that all of that traffic at line rate, wire rate, stays off of the router CPU. So the router CPU is really reserved for that layer 3 and above intelligent features that you need for your WAN connectivity, for any of your advanced features that need to take place on the router. We're keeping that layer 2 local LAN traffic off of the router's big brain CPU. Now, another situation we have here is when a module wants to communicate directly with an older module, for example, a legacy module. We do have the capability of going directly from a newer module up through the MGF to the CPU, because we do have this trunk interface here. So regardless of what the destination interface looks like, that UCSE series application can go out the same interface, can go out the same VLAN interface through the MGF. It will just find its layer 3 gateway, its layer 3 destination gateway address through the router CPU. This is typically going to be a virtual machine running on a UCSE series. It's going to configure just like any other server, and you'll enter an IP address. You'll enter a default gateway. In this case, the default gateway is going to be the router CPU. Once that packet gets up to the router CPU, it's then going to say, okay, I know at layer 3 what to do with this packet. In this case, it's actually going to be to send this packet out one of my legacy interfaces, one of my HWIC interfaces. This could be a T1, E1 interface, for example, and then strictly ride out onto the wire out to the WAN interface there. So that's your normal packet flow from one module to the next. Now, the 4451X changes things just a little bit. It's going to be a much larger device, it's going to be a much larger block diagram, a little bit more complicated here. And of course, we're going to have a separate control plane and data plane inside of the system itself. So separate control plane for actually running the routing protocols, for actually doing the forwarding in the system, and a separate data plane for actually doing the regular forwarding of packets. And of course, we have lots of individual components that support this overall function. Of course, anything in red here is going to be the core functionality of the system. Anything in yellow are going to be our individual modules, and all of the green stuff are really support cast. So from a high level, you can sort of ignore those since they really don't get involved in your direct packet forwarding through the system. If you think back to that ISR G2 block diagram, this is really analogous to the router CPU. In this case, instead of just a single CPU, we have a control plane and a data plane CPU complex, and then the multi-gigabit fabric, which we have here, that performs exactly the same function. So for module-to-module communication, we have the exact same thing with the multi-gigabit fabric. Packet flow in a 4451 is going to look very similar to that ISR G2 packet flow. The biggest difference is really going to be what happens first, and that is that our control plane CPU is going to be programming our data plane cores. So basically, we're running all of our routing protocols, building all of our forwarding tables. All of that information gets pushed down into the data plane, and then the data plane is going to act on all of our packets, all of our flows, going through the system at layer 3 and above. Of course, the multi-gigabit fabric is still there for layer 2 and below for direct connectivity within the branch from one module to the next. Normal packet flow is going to look exactly the same. So packets coming in this case from a user on our front panel gigabit Ethernet ports that tie directly into our data plane CPUs is going to go straight through the data plane, out through the multi-gigabit fabric, and then down in this case through one of our new network interface modules. Now, one thing you will notice is that in this 4451X, we don't have that out-of-band connectivity for our legacy interfaces because all of our traffic in this case goes through the multi-gigabit fabric. And that's true for all modules. And that's one of the things we've been able to do with the 4451X is we dramatically oversized the multi-gigabit fabric. It's significantly more beefy than it really needs to be in this system, so it can handle all of the packet processing through the entire system. It's also a much beefier connection between the data plane and the multi-gigabit fabric. It really streamlines how our interfaces talk to one another in a 4451X. Moving on, the same type of packet flow, front panel gigabit Ethernet, in this case connecting to one of the newer SMX modules. In this case, this could be a UCSE series, just like in our previous example. That's going to go straight through our data plane. Same thing if we have a network interface module. In this case, talking to an SMX, this is going to be at layer 2. This can all happen directly through the multi-gigabit fabric itself. And again, this is just like on the ISR G2 with interfaces talking directly at layer 2. Now, what happens, one of the cool things about the 4451X is that we do have the capability of bundling in running services directly on the router itself in a service container. That service container actually runs in a virtual machine running up in that control and services plane CPU cores there. So the first service that we have is going to be ISR-WAAS. It's the first service we have on the 4451X. And ISR-WAAS is going to accelerate some of our wide area application traffic, some of our wide area traffic. So basically, if we have traffic coming in from the LAN, in this case, a front panel gigabit Ethernet interface, it's going to go straight to the services plane. The data plane itself is actually going to be running AppNav, which is going to be doing flow awareness and actually sending all of that traffic that can be accelerated up to ISR-WAAS running in the services plane. ISR-WAAS then is going to send that recompressed, that accelerated information, so which is going to be smaller packets, a smaller packet flow, out to the WAN interface. In this case, it was going out our SMX interface, because that is essentially going to be our WAN interface in this case. And then the reverse is going to happen in exactly the same flow. So all traffic in this case going to a service container is going to go through the multi-gigabit fabric up through the data plane, which will then make the intelligent flow decision based on what traffic needs to go to a service container and what traffic doesn't. Send the appropriate traffic to the service container and then wait for the reply back, and then reinsert that traffic into the data plane. And that's the typical packet flow for a service container running within the 4451X. So that's really a high-level packet flow, basically how packets get into and get out of an ISR G2 and an ISR 4451X system, the ISRs as a whole. I've got some links here for some more information, some really useful links. If you're looking for just some general information on the ISRs, go go/ISR on the Cisco.com page is going to take you directly to the ISR family page, where you can find out lots of information about the whole family, the ISR G2 family and the 4451X. If you're just interested in the specifically in the new 4451X platform, you can go straight to the cisco.com/go/4400. We'll take you directly there. The multi-gigabit fabric, we actually have several white papers that go a little bit more into detail. I'm probably actually going to do a video on how to configure and set up the multi-gigabit fabric for direct module-to-module communication, since it is a little bit more involved and a little more complex than what you might be used to. I'll do a video on that in probably a few days here. So here's actually the link directly to the multi-gigabit fabric white paper. Honestly, the easiest thing to do is just to go to Google and do a search for Cisco multi-gigabit fabric. This is the first link that's going to come up. So thank you very much, folks. Thanks for your time. Look for the next in the series here. We'll probably be doing a multi-gigabit fabric video immediately after this one that'll dive into that capability even further.